Okay, so what I want to talk about first, I love this little website. It doesn't work on your iPads, or I would let you guys all like mess with it on your iPads. We're gonna go with like, which direction? You guys want to go large or small first?
Huge.
Large. Hands up for large first?
Large.
Hands up for small first. Alright, we'll go in the direction of big. Alright, so we see the obvious human size. Sunflowers can get taller than humans. Japanese spider crabs. Anybody see that? That's super creepy. Statue of Liberty.
Eiffel Tower.
Yeah, Eiffel Tower, Titanic. We have some big stuff here. Titanic was massive. Whoops.
Apparently they're building was.
Yeah, was.
They're building an exact
You know they re-released Titanic in 3D, right? There,
Yeah.
yeah, and there were actually people that went to go see it that were like, wait, did Titanic really happen? Hoover Dam.
Yeah.
Huge.
What is the big
Way big. What? Half Dome is a rock. Is a giant rock somewhere. I can Google it. Yosemite National Park in California. Okay. Still bigger?
Yeah.
So we're at 1,000 meters, which is a kilometer. Okay, so we have things that are a kilometer. So Half Dome is a bit more than a kilometer. Okay, so can we compare that Vatican City is smaller than Angel Falls? At least Angel Falls in height versus Vatican City in length and width. Okay, Boeing Everett factory, that's like where they make Boeing 747s. Is about the same size as Vatican City. Did you guys study that in history? It's interesting how it became its own state. All right. Uluru. Alright, so this is also interesting here. An AM radio wavelength is big. It has a huge altitude, amplitude.
I like the lure.
Okay. A little further. Should we keep going? Central Park? Central Park, look how big Central Park is compared to Vatican City. That's in New York. So like the pond in Central Park is the same size as Vatican City.
Nice. Probably a little bigger.
Okay, this here, I believe, is an asteroid. Okay, so we have an asteroid that's the same size or bigger, slightly bigger than stuff on Earth. Okay. Still bigger?
Yeah.
Okay.
Continue on.
Mount Everest. Alright, Halley's Comet is about the same size as Mount Everest. So a neutron star, do we remember, is that the densest or more or less dense than a white dwarf? The densest. So we're talking about cramming a crazy amount of density and mass into the size of a marathon, which is 26 miles, or under the size of Rhode Island, which is also about 26. It's very small. Alright, we'll keep going.
Yeah.
Italy, Ceres, what is that? That is a dwarf planet. Can we look over here to the left? The Great Barrier Reef, bigger than Texas and Italy, and approximately so. I mean, obviously not in mass, but we're talking in length and stuff. Ganymede, yes. All right, so we'll keep going. All right, so now we can compare. Look at this: the size of the U.S. to the Great Barrier Reef. And then the Great Barrier Reef to the Great Wall of China. Mercury, approximately the size of the U.S. Let us think about diameter going across. Okay, they look about the same too. Mercury, Ganymede, Callisto, these two moons of Jupiter, Galilean moons. Earth. What is Earth's twin planet? Venus, which you can see it up here. Okay, keep going.
Yeah.
Okay, go bigger. Sirius B. This is
That's the blue stuff.
this is a no. So Minecraft world is approximately the size of Neptune.
Never used to be available.
Proxima Centauri, what is that? Proxima. Does anybody know what proxy means?
Planet.
Yeah, it's a proximal or proxy is what's near to you. So what's Proxima Centauri?
I thought Saturn was huge.
Near to us. It is the nearest star to us besides the sun. Proxima Centauri. Okay. Or a gigameter. So the sun, bigger than Proxima Centauri, similar in size to Alpha Centauri A and B. I'll scroll out just a smidgen. Vega spins so quickly it bulges. However, we see it pull on so it looks circular. So where we are, it looks like just a circular star, but it rotates so fast that like the gravity, it kind of...
I thought the sun was like the biggest thing in the world.
It's not in the way.
Alright, so Mitch is being overwhelmed. Is anybody else feeling overwhelmed? Should we stop?
No.
Okay.
Don't wait for
Slow till the end.
I saw things.
Alright.
I like that. Yeah.
Alright, so now we're in terms of distance of Earth to Sun, which is 93 million miles.
I can't see it.
1,000 million, billion, trillion meters. So now we're approaching 1 light year. We are approaching 1 light year distance. Okay, in size. Pistol star. One of the most luminous stars. Now look at it. Look, can you guys see it like emanating light?
Yeah.
Kind of pulsates.
Yeah. Not because of its luminosity, but because it's in the Eagle Nebula.
Illuminati. And now it's
34
the
years,
horizon,
it's
right?
traveled 17 billion kilometers, furthest any man-made object has gone.
Do we even know where it is?
Yes. Okay.
How's it traveled that far in like only 34 years?
I mean, you send it out, there's no gravity pulling it, and there's no friction, it's just going to keep drifting.
But wouldn't it take like light years and light years to get somewhere?
It's been traveling for 34 years, though. It's been traveling for a long time.
That's when you cover.
And it's traveling pretty fast. Alright, so now we are at light year distances. So, Cat's Eye Nebula, Blinking Nebula, Hourglass Nebula, all approximately 1 light year or less across.
So it's approximately.
So can we remember way back to like human size still?
Yeah.
Can we remember back to that Minecraft world size? Probably can't still see it. Okay. Does anybody know what the Oort cloud is?
A black cloud.
It is the outermost region of our solar system. It has like weird, nasty cold things out there. Comets fill the region. It's the very far boundary of the sun's gravitational pull. Right now, around this parsec size, we're 3.3 light years across. So we are 3.3 times 9.4 trillion kilometers.
Cone Nebula.
There is the Cone Nebula.
Gigantic.
Bigger than a parsec, maybe twice as big, so like 6 light years or so across. 7. Alright, then we also have approximately a parsec, distance from the sun to our nearest star, Proxima Centauri. Alright. Does anybody know what these ones are here? Pillars of creation. Alright, I can stop anytime. Okay. We'll go to the edge. Orion Nebula. Here is the Eagle Nebula. And you can kind of see right in there the spire here and the pillars of creation are both in there. Okay? So Eagle Nebula, we are at an exameter. 1,000 million, billion, trillion, quadrillion. We're at 1 quadrillion kilometers.
Are we still in the
We're not, don't think of location. This is size. We're talking about magnitude. These are not where things are located, but the size of them. Here's the North America Nebula. That does kind of look like, a little bit, like North America. A little bit. Omega Centauri. Globular cluster. It is the brightest globular cluster. Small Magellanic Cloud, only called small because it is smaller than the galaxy nearest to it. This is 7,000 light years across. There is a supermassive black hole in the center of this galaxy.
I want to call you that the.
You guys kind of aren't paying attention anymore. I'm going to stop. Pinwheel Galaxy, Andromeda Galaxy, huge. That's our nearest galaxy. The Milky Way is twin. That is 150,000 light years away. Whirlpool Galaxy,
Oh, I like the tadpole.
Tadpole Galaxy, because we can see them with the telescope.
Really?
The distance Earth has traveled relative to the sun.
So
So that's how the distance Earth has traveled, like how, since it has been in existence. So we're at, it's traveled almost 500,000 light years relative to the sun since its formation, 4.5 billion years ago. Distance to the Andromeda Galaxy, this was 2 million light years away. So if we want to go to the nearest galaxy, it was 2 million light years.
What's the yellow?
We're at a Yoda meter.
No.
We're there
I don't
yet?
know what that is.
Distance to the Hubble Deep Field. So the Hubble Deep Field, that's the telescope. It can see 12.7 billion light years away.
That's crazy.
So what that means is that that Hubble telescope is a time machine. So we are basically done. To the end.
universe.
Alright, so observable universe. This is what we can see when we look in any direction away. That's what we can see. But is that all that there is?
No.
Yeah. Alright, how old is the universe? We expect that the universe is 13.7 billion years old. The universe itself. Okay? Currently, the radius is 46 billion light years across. So can we remember like the little light year distances that we were looking at, these little nebula and stuff? 46 billion light years across. That's currently.
How do you know the dynamic?
We know what we can see right now. The observable universe, what we can see from one end to the other that we can see is 46 billion light years. Hopefully we can see farther. Yeah, we might not be able to, but somebody will be able to. Has the universe always been 46 billion light years across? Like, or our observable universe always been that?
No.
Has the universe always been the size it is?
Yes.
Absolutely not.
Isn't it ever expanding?
It is ever expanding. Now, I'm going to take you guys back on a little brain trip here. Okay? Now, this is our observable universe. It's 13.7 billion years old. Once upon a time, 13.7 billion years ago, there was a Big Bang. Okay? Now I'm going to show you guys. We're going to zip way, way back. All right, I'm going to go kind of fast. Go way back, eventually to...
It's starting to scare me.
Everybody, eyes open for Minecraft. There goes Minecraft World! Okay, so now we're back, approximately back to human size.
You know, I thought the sun.
Human, I see.
What is it before you?
Alright, so we're human size. We're going to go down to... Okay, phospholipid bilayer, that's what your cells are made of.
Yay!
Hydrogen atoms, helium atoms. So this is what stars use. Hydrogen and helium, using that stuff. Can we remember how much bigger? Look at the little slider bar. Okay, these are tiny. These are tiny. Proton, neutrons, very small. And we'll keep going. Is that protons, neutrons, and electrons are made of quarks. Okay, and smaller than quarks, we actually believe. Have you guys heard of string theory? Okay, so string. Okay, did you see how far down, how tiny? So, as in string theory. Strings are one-dimensional but vibrate in all other dimensions. This string, however, is not the same string used for flying kites. That string is between 10 to the 32nd and 10 to the 33 times larger. So that's actually like a trillion times larger. Okay? Quantum foam, basically the thing that the universe is made of. Space-time foam.
So it's like
Okay.
So we're not made
Now-
of atoms, we're made of foam.
Yes, or strings.
Stardust.
Now, the reason I took you guys all the way down to this. So, now, I don't want to overwhelm you guys, so I'm going to warn you that this is going to be overwhelming. Now, picture this quantum foam. Like, this is string, Planck length. We are at, like, tiny octometers. We're, like, just like an infinitesimally small space. That is where the universe was before the Big Bang. Every piece of matter in the universe was in an incredibly, like, a size that you can't even comprehend, small. And then, boom. And it all started expanding. 13.7 million years ago. Does anybody have any questions?